Agriculture, the world's most vital industry, is on the verge of a digital makeover. On Interconnected, a new show by Equinix that explores the hidden infrastructure behind our connected future, they explore the ways edge computing, AI, and other modern innovations are reshaping how food is grown, sent, and delivered. Global agri-food leader Christine Gould lays out the digital challenges farmers face and where change is already sprouting. Listen on Spotify or wherever you get your podcasts.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for a quick intro. And one thing I wanted to mention that I actually been meaning to mention, but I keep forgetting. All Things Open here in Raleigh is coming up next week. And sorry for the late notice, but for those that will be attending the show, I actually will be there. The folks for the event were nice enough to give me a complimentary pass, and going to be attending the event and would love to meet up with some folks. If you are interested and you will be at the event, shoot me an email, aaron@thecloudcast.net. And like I said, would love to see some folks out there. And I really love the show every year. It's certainly one of the premier events, both in the industry, but also it's great because it's in my hometown. So it's certainly love that as well. Now, let's move on to our guest and our interview for this week. We have one that is, I'm going to call it security adjacent. There's this concept that's been really kind of coming up in the industry of, okay, one of the ways to use AI is AI scams, and certainly phishing. And how can you then use AI to prevent this? And this AI cat and mouse game that kind of happens of the AIs get smarter to scam folks, and then the AIs get smarter to detect everything. And it's a pretty fascinating conversation and a pretty fascinating topic. And for that, we're going to be talking about that, and that's going to be coming up right after this break.
Today's show is brought to you by TestCube. Testing applications in Kubernetes doesn't have to be complicated. TestCube is your go-to platform for cloud-native continuous testing. With TestCube, you can orchestrate, scale, and automate tests effortlessly right within Kubernetes, catching issues early and deploying with confidence. Try it out today and see why engineering teams trust TestCube to keep their testing simple and scalable. Your tests, your tools, your infrastructure, finally together. Check it out at testcube.io/cloudcast.
Hello, everyone, and we are back. This week, we've got a really interesting topic, and it's something I've been definitely hearing more and more about. And the idea here is the rise and also the prevention, a little bit of this cat and mouse games that goes on with AI scams, AI phishing, and all of those other things like that. And so for that, we have Alan Lefort, co-founder and CEO at Strongest Layer. So first of all, Alan, welcome to the show. And yes, absolutely. And tell everyone a little bit about your background and your involvement in cybersecurity.
Absolutely. This is the part that reminds me that I'm older than I look. But I've been in cybersecurity since 1997 when I was a network admin for a small regional ISP. And it was in those early days before security was so much a career that I understood there were these things called viruses. There was things called denial of service attacks. There was these network attacks that could propagate, a virus in weeks. And that was scary, right? And you fast forward to today, 2025, and these things happen in seconds and they're done in bulk and they're all orchestrated and so many methods of attack. So it's gotten so much more sophisticated. But I think what hooked me then and kept me in security for, the 20 some odd years, was it's a puzzle. It's an interesting puzzle because you have a limited amount of data. You're trying to guess what's going on. There is an element of cat and mouse. And it's just so interesting to try and figure out what's going on. And so to my rational brain, to my engineer brain, that just always appealed to me. since those days of being a network administrator, I went on to build out security portfolios for large telcos. I've worked in small startups that do security information event management in the early 2000s. Then I went to as VP of product to AVG, which was the first big freemium antivirus. I spent a couple years in Europe running a product there. Then came back stateside and worked for an amazing startup called HiTrust that was securing but cloud workloads at the time when cloud was becoming a thing. And from there, I went on to McAfee to run their product management, their strategy, and eventually a business GM. And then Proofpoint took note and asked me to come and help them with security awareness and run that business unit for them, because my career had been 50-50 consumer security and enterprise security. And security awareness and email security touch on both, because there's the element of you're trying to stop the hackers, but you've got the need to engage with employees and help them make better decisions. And so they hired me for that, did that for about 4 years. And then after I left Proofpoint, it was time to start a new thing. And I started my search, and I stumbled across this great team and technology called Strongest Layer, and joined them as a co-founder. And now we're reinventing email security for the AI era.
I love it. I love it. And so let's start with that core challenge and what you're trying to solve there, because I've seen, like you've said, if only AI could defend against weaponized AI. And I love that term, weaponized AI, because, I mean, here's the thing. Like, it's not like phishing is new. It's not like email scams are new. Like, all of this stuff has been happening for so long. But I think, if anything, agentic AI and this ability to just kind of not just automate things, but really turn it up a notch has really just kind of poured gasoline on this fire, right? And so, like, what is the specific gap between kind of traditional approaches, and what did you kind of identify as we moved into this AI, gosh, what do you even want to call it? AI phishing and AI scams kind of, era.
Yeah, well, I
let's start there
and call it, the singularity or anything silly like that. But it's definitely a step change. Well, let's talk about it, though. I think let's talk pre-AI, right? So pre-AI, there was a set of attacks called phishing attacks that were essentially, and they're called phishing because when you phish, you put on a lure. You're trying to reel someone in with a shiny lure. Phishing attacks kind of come from that reality where you create an offer that seems too good to be true, and people click on it, and that takes them to somewhere where they can either gather their credentials, get their credit card, all kinds of nefarious intent. And when they were being done manually, and often maybe in countries outside of North America, where the English wasn't perfect, you would train people to spot the flaws. Hey, if it's got misspellings, don't click on it. Hey, if the URL looks too long and weird, don't click on it. Hey, when you hover and the link is one thing, but the name is another, don't click on it, right? So just very obvious tells. And I think what AI has done is the idea that you could train an average human to spot something that looks weird, off, abnormal, worked for a while. But what happens when it's no longer a group of folks on a shoestring budget trying to do this manually, but they now have access to the same AI tools that we all have access to for $20 a month? Well, all of a sudden, those obvious spelling mistakes go away. Those very clumsy attempts at hiding in plain sight go away. And it now starts to look like something that was an expert designed it to fool an expert, not a non-expert fooling a non-expert. And that's the biggest shift. And the way I think about it is, I think of I'm at that age where now my last daughter has went to college. And so I'm a little bit wistful in that regard. But, it reminds me of like when my daughter would come and say, Daddy, 4 or 5 years old, she drew you a picture. And she's like, look, it looks just like you. And I'm like, of course it does. I could spot the difference. We are now in an era, and that's what phishing was like a little bit, like, oh, that looks like a kid drew it. It must not be real. Now you zoom to today, and the challenge is more akin to, hey, we just discovered this painting from 600 years ago. Is it authentic? Is it real? And now you're into that world of You need experts who are experts among experts to try and authenticate a piece and see if it's real or not. And that is what we're putting in front of employees now. We're like saying, prove that this thing is real, even though it's a perfectly identical copy and you can't tell the difference. I think that's what AI has brought in terms of the challenge for the employees, but also for the challenge of the technologies in place, because those technologies are staffed by people. There are people writing rules to stop and catch these things. And those people are now being fooled quite often because the replicas are so good, right? So I think AI, if I was to summarize it, is bringing, perfect mimicry. So it's really hard to spot the difference. I think the other thing they're doing is a cost reduction, which is just massive. So Harvard did a study in November 2024, and I stumbled on it, and it was a great study. They asked themselves this question: if we use AI to phish employees, will the click rates go up? And that was part of their study. And then what could we observe on that? And they had 3 conclusions that were scary. The first one was when you used AI to craft phishing scenarios against employees that were trained, that all had been trained on security awareness, you got a 60% click rate. That is a terrible number. And for people that don't spend a lot of time with math, like Russian roulette, which I would never do, is a 1 in 6 chance. That's 17%. When you get to, a 60% rate, you are now in like Russian roulette with like more than half the chamber loaded, right? So the odds of you getting attacked are just incredibly high. So that stat was very troubling. The second one was they found that they could profile employees inside the company using the data that they put on Facebook, on LinkedIn, on all social media, Twitter, X, whatever you want to call it these days. That data, 88% of the time, would allow hackers to profile employees and personalize the attack. Okay, so you have, and do it at 95% cost reduction. So that was that. So you have economics. It just became accessible to everyone. Everyone can be profiled so that the email is personalized, and it can just be done automatically at scale, right? Those 3 developments are what is breaking email security today. And in a second, I'll explain why, but I'll stop there because it looks like you've got some.
No, and it reminds me of like the rise of like in the earlier days of like the rootkits and script kiddies and kind of, stuff like that, of like, it just became economies of scale. It just became accessible, if you will. Right.
Well, but that's a great point.
Go ahead.
On the rootkits.
And let me ask you this, because like when I think about everything you just said, the other thing I really think about too, especially when you're talking about profiling, and kind of, be agentic AI kind of doing research on targets, how does the multimodal and the modalities fit into this as well? Because a lot of folks out there today, when they think of Gen AI, they just think of text, right? And how does the different modalities fit into this potentially as well?
Oh no, that's a huge that's a very interesting area to go into. What it reminded me, though, when you asked that question of multimodal, if we change that word a little bit to multi-channel, you just basically are using a marketing word.
Yep.
Right. And so the simplest way to say what will the hackers do with this new technology and what approaches will they attempt? Look to the marketers, because they're doing the same thing. They are harvesting people for money. One for good purposes, the other one for not so good purposes. But what I think also AI has done is that it has made marketing and phishing emails indistinguishable. So it's even doubly bad for the end user. And I'll come back to your question, but I want to share this thought, right? When you think about what makes a phishing campaign, there's usually a pilfered email list of random employees, whatever, bought on the dark web, harvested in some way. There's usually some sort of campaign that could be multi-stage. And then they will try and harvest people's credentials, et cetera, et cetera. And it's usually sometimes multiple emails across multiple mediums. Marketing is the same way. They're using AI to personalize a campaign. By personalize, meaning they're buying external signals about you, I just changed my job. I just got promoted. I'm at a new company. I'm out there researching technology and I made a comment on a website. Someone harvested it. It went into a tool. And now they're going to personalize that sequence based on all that data, right? And then hopefully I'm going to enroll into a demo, a webinar. That's exactly what the phishing people are doing. And some of the techniques they tell the marketers to do, they're like, hey, because spam is a problem, you need to have multiple lookalike domains to warm up the senders and all that. Well, what do phishing attacks do? They spin up lookalike domains, partly for deception, also partly for deliverability. So we have now reached the point, because of AI, that you can't tell a multi-channel campaign from a multi-stage phishing campaign, because it's the exact same use case, one for good, one for bad. And how would an employee know? So it is a problem. But we are seeing those types of attacks. In fact, one of the other reasons you see these multi-challenge attacks is because, hackers are super rational. People think of them as they're evil geniuses, but they're just hyper rational and intellectual smart people trying to make money in this particular way. And so they will go wherever there's the least resistance. Like, why would you go and try and break down a steel door when the window's open? Just go through the window. Up until today, the easiest place to get through the open window has been, sadly, email security. Over 90% of breaches originate with email. So sadly, it's not the window that's open, it's kind of the door. That's a problem. And so, I think to your original question about the multi-channel approach, is they're finding ways where there's chinks in the armor, where it's easy to go through. And so one example we saw, which was very interesting, is it combined 3 techniques that each individual technique did not get past the security. But when combined, like they did get past, I should say, but when combined, it was nefarious. So one we saw was from a customer that got an email, and the subject, it said to come from Amazon Japan. The subject was in Japanese, but it redirected to a non-Amazon website written with some Cyrillic characters to look like that, and then had a different call to action completely in the body. Now, the email came from a reputable domain, a reputable sender, passed all of the typical authentication checks you'd want, DMARC, DKIM, SPF, they were all fine. But when you analyze them all together, that's when you realize these things don't make sense together. Something is off. And it turns out it was an attack. As you drilled in, you could be like, okay, this is a very sophisticated and very subtle BEC. So what were the attackers exploiting? We believe that what they were exploiting is that current technologies try and decode the language, but they have a bias towards English. Rule writing was mostly written by people in English and North American companies. And that's the biggest market. So there's a bias towards English. And so we think they were trying to exploit the fact that there's just weaker coverage in other languages and putting the appeal to urgency in Japanese, where they assumed the rules weren't there. And it was, when we saw it, it was passed by a secure email gateway that was rules-based. And so we think the attackers figured that when you introduce multiple languages, the system picks the best language, not all languages at once. And that was their trick to get in. And we think they'll just continue to find those kinds of little places where, why break the door down when there's a path straight in? You might have to squeeze through, but it's there. And I think AI is really good at doing all these permutations to try and find out where is that easy in and then exploit it fast.
I like that. And this reminds me of, so again, go back to, so my day job is marketing. In marketing, there's definitely a term of like net phishing versus spear phishing. And it's basically, are you trying to go like one to many, or are you trying to go one to one? And it definitely seems like, especially when it comes to phishing and you're talking about AI profiling, you've maybe done net phishing out of necessity previously, but now you're able to do spear phishing going forward. Yeah. And so it's just that complexity turned up, if you will.
Well, it's funny you say that. I think if I was to put that in marketing terms for you, and what's going on with the attackers is they went from doing old school mail merges on a template to now they're doing account-based marketing that's got intent research. It's going specific to personas. It's focusing on them, but it's not expensive because they're using LLMs to do it.
Yes. Yeah. Makes perfect sense. So let's talk, while we're talking about LLMs, let's think about that for a little bit, because there's always this concept, especially in pretty much everything AI. And I feel like AI, it's like the early days of cloud, right? Everything was accused of cloud washing. Like everything you had to sprinkle some cloud in it, and now you got to sprinkle some AI in it, right? And a lot of organizations and a lot of products are getting accused of this like AI washing. And I'll just use the term of like LLM as an add-on or LLM, baked into it, meaning like it was built around this. And so you have this concept of like trace, like threat reasoning and AI correlation engine, like it's an architecture. And tell everyone like a little bit of like LLM in versus LLM add-on, and like a little bit of this architecture difference for threat detection.
Yeah, I think that the key thing that we think is unique is that two things when we talk about the LLM as master. And it's really about, are we putting the LLM at the center of the major decisions, or is it just kind of like a consultant we call when we have a question? And so, in our world, that the way we think about the LLM and the way we should use it has a little bit to do with how we think about the evolution of LLMs and the adversary. And I'm going to go a little bit on a tangent, but it's going to make sense.
Go ahead.
When I look at how LLMs have evolved and why they've evolved, in my personal taxonomy, we're in a third generation of that use. And I'm going to go before the LLM, and I'm going to say, if you really look at neural networks and all that, a lot of that body of knowledge was really around graph theory and how to bring that into search. Google was at the pioneer of like, we need to find stuff and we need to find it fast. And we need to find all the relationships and connections. So you can kind of say universal search, beginnings of LLM. Then, and I wasn't in the boardroom, but I assume that at some point Google realized, hey, if we could do this in every language, we would be loaded. And if people could communicate in such a way that their language or their difference of language wasn't a boundary, we would do more business. And so you ended up with universal translation. And as we know, a lot of the transformers, BERT, et cetera, came out of Google. I think we've now reached, and maybe not with Google, but certainly with DeepSeek coming out, we reached this part where we went from universal search, universal translation. I would argue we're at the early stages of a universal algorithm. Right? Because you just tell the LLM how you want it to think, you give it some data, and it basically reconfigures and spits out. And so my view is, if the attackers have an LLM and we have an LLM, and let's just say they haven't jailbroken theirs and we're just using the same open source ones, who wins if we both have the same universal algorithm? And the answer is whoever has more data. Right? So our ability to bring more signals into the LLM, to see more signals at once, signals of normality, signals of abnormality, context around the business, that will be the thing that results in us always beating out the adversary, because they can never have as much data about what's going inside the organization as to what they can infer from the outside. And so that 88% won't matter because our knowledge is 100% and it's much deeper. So that's how we think about the LLM and why it's so central that it becomes the reasoning engine that is seeing all these different signals and multiple stages to control for cost and, false positives and all that. But that's the fundamental assumption we're making.
I love it. I love it. And go ahead, please. Go ahead, Alan.
And what excites me a lot about that is that we're finally changing a dynamic that I've never liked in the threat detection part of the security industry, which is we always start off by failing. And that sounds like a really bold topic, but a lot of where antivirus came from, and then a lot of the security industry was from, it's in the word, it's from viruses, it's from epidemics and outbreaks, right? And as we know, when epidemics and outbreaks, the way it works is we do contact tracing. We figured out who got sick, how they got sick. We interview them. We take blood tests, et cetera. And then a picture forms of how the thing works and how we could potentially detect it and block it. It's true in the organic world. It's also true in the digital world, right? So the dirty secret of all these pattern matching systems, which we call generation one systems, is to stop an attack, someone had to be a victim, and generally many someones, until we can extract the pattern to generate the signature to push it out so that future attacks that depend on this approach will succeed. Now, if you recall earlier, I talked about how AI is making it so you can personalize everything. Now, if you had to have seen the attack before to stop it, and AI can personalize and hyper-personalize every attack such that the data set of that attack is n equals 1, will there ever be a rule written to stop it? That is the fundamental architectural problem. Now, generation 2 architectures, which we'd say are machine learning models, and some people have classified as AI, I would argue that they're just advanced pattern matching. They're not reasoning. They're just detecting more advanced patterns. But they have the same requirement. They're models that need to be statistically trained on a large data set. Too small a data set, you end up with false correlations, false positives. Too many signals, and again, you end up with the other problem of how do you model all that and the cost of it? And so they are still, for the most part, going to be somewhat blind to novel attacks, because where will they find a big enough data set to understand and model those patterns? So that's why we believe that an AI native reasoning engine, where all the data starts with the LLM, ends with the LLM, is the right architecture for, this period that we're going into.
Yeah. And it almost reminds me of, so a couple thoughts there. I remember back in your AVG days, the virus signatures, and, you got to keep your virus signatures up to date and things like that. But then also too, I think of in the early, especially in the ransomware days, it was it was basically a bunch of pattern detection. And what did it look like? It was basically look for, hey, something's getting encrypted, all of a sudden, and that, hey, why is this getting encrypted? That's weird, and that shouldn't be happening. So let's raise some alarms, right? And so I feel like the thing with exactly what you're saying of we've always been in reactive mode, and we've always been on our back on our heels, right?
Yeah.
And AI is potentially enabling us to move to more of a predictive security model. Mm-hmm. And so what I'm kind of wondering here is, okay, in this deployment model, what exactly will how does it move beyond pattern detection, I guess is what I'm trying to say, of okay, how does the LLM take reasoning and apply some kind of business context, but also at the same time, not expose the data and try and come, is it it's just basically coming to almost I don't want to say second guessing, but almost guessing intent? Does it almost become intent based going forward? Or tell me what the next generation looks like for predictive.
So it is. And I think predictive sounds, I think, very fancy, a little bit crystal ballish. But what I think I'd say architecturally, the first thing we set out to do is say it's unacceptable that the first attack always succeeds. And if there's never going to be more than a first attack, it means that we have to have everything in place to be able to detect on the data we have on the first email we've seen. So how do you bring that? Well, one of the things we realized was to really be able to discover intent, and where intent was asking people to deviate from normal, you really need to understand normal. And so one of the unique things that we did in our architecture, because of the nuance that's coming, that we're seeing already, was we knew that it could be a false positive nightmare because of that nuance. And that generation of pattern matching systems or ML systems have one thing in common. They are only hunting for guilt. So think of it as a court system where you basically get accused, you stand up in front of the judge, and you cross your fingers. There's no one to defend you. That is how all email systems are generally built. And we thought it through and we said, we need to bring more signals to bear, but more importantly, we need to solve this false positive, false negative tension, right? And that tension in typical systems, for those who've managed them, is if I get really aggressive on detection, I'll catch a lot of things, but I'm trying to drag some things that aren't real detections because we're just a little overzealous. Now, if I want to tune down the false positives, then I get more conservative, and then I'm going to miss some detections. And so it's just been this constant sliding window. And we said, we don't want that anymore. So the way I would say we've set up our system is that every email will get its day in court. There will be an LLM that is getting all this evidence of normality that will say, hey, this email looks normal. I'm going to advocate that let it through. It's normal. We have another LLM who's like a prosecutor, not a defender, a prosecutor who's all the evidence of abnormality and says, Your Honor, guilty. And then you have a third-party judge, call that trace, that looks at those pieces and says, based on the evidence, it is a detection, and here's why. And what's unique about that process is we actually share all of that reasoning. Here's why it's good. Here's why it's bad. Here's our final decision in our product with full explainability, because things are so nuanced that they won't be able to do their job in checking these out unless we provide that explainability. And so that approach, I think, is very unique to us and is allowing us to rethink, how we do detection. So that prosecutor defender motion, kind of like the day in court, has worked out really well. Now, a second thing we've done, though, that we said, email is literally the corporate lifeblood. It is all of your IP. It is everything about your workers. It's all about your processes. Everything's encoded in email. Like 95% of what a company does is somewhere in an email. And the idea that you would train an LLM, whether it's normal and abnormal, on that data, rightfully scares customers, right? So we knew day one, we cannot ever use the email to train models. And so all of the things we've built, we've created what we call a zero memory architecture. So when your email comes into the LLM, we have all the advanced reasoning, all the context to make a decision. But once that decision is done, it's like we never saw it. So the way we like to say it is, we've created something with the reasoning power of 1,000 security analysts and the memory of a goldfish.
I like that. And let me also add this, because I really think so. The other thing, I think there's almost been a running joke developing in the AI industry, especially around agentic AI, of you look at a lot of the big keynotes, and for longest time, it was always like, what is agentic AI? It's I can make dinner reservations or book a flight. And it's like, oh, come on. That's just not a great example. But this is a really good example of both reasoning and agentic AI. So recent kind of forward steps from Gen AI into kind of this next generation. And this is that next generation architectures at work. And so I just wanted to point that out. Let me just ask you this, Alan, to kind of close us out there. If someone out there is really interested in this and wants to learn more and wants to get started, what is the best place for them to get started?
I would say, we've written and we've had coverage on a couple media articles that are out there about us. So if you're like, hey, I want to hear it from a third party, whether that's SC Media or Dark Reading, there's a great piece on us in unite.ai. And I bring these up because they're not us giving our own commercial, but other folks who vetted us and thought, that we're noteworthy. But of course, we would love to hear from anyone. So if you go to strongestlayer.com and just hit the contact us form, I get copied on those. So does my our chief product officer. We love to talk to people about our technology and what we're doing. Even if you're not in the market and you just want to talk the tech because you're interested, we love telling our story. We love sharing what we've done, and we'd love to hear from you.
Fantastic. Alan, very much appreciate your time this week. And for Brian and myself, everyone out there, thank you very much for listening this week. If you enjoy the show, please tell a friend. Please, if you're able to leave a review wherever you get your podcast, do that as well. And of course, we're always open to feedback and suggestions for guests as well. That's it for this week. And we enjoy your time, Alan. And thank you everyone out there for listening. And we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.